So the only one absent, I guess, is Mr. Montanez, but some of you may watch this again. So I think, did I actually explain this to any of you yesterday?
Yeah,
I did, okay. So let's look at number 3 here. And the question is, in decimal form, how much of this would be shaded? Okay, so I could put 0 point, well, we've got one entire row, so we know that's 1/10. So this is one row completely shaded in, and then we have 1, 2, 3, 4, 5, 6, 7, 8 more shaded in. And then they've got, basically, it looks like just one row of that one shaded in. So let me pull sticks here, see if somebody can tell me. Mr. Montanez is not here. Mr. Paulson, what do you think this would be then? So we've got 1 plus 8, that would be?
1 plus 8 is 9.
No. Well, 1 plus 8 is 9, you're right, but how many total are shaded? This is a whole one, so this would be 10.
18.
There's 18 shaded, okay. And then there's a partial one that's shaded here. What number would I put here? 1. Very good. So this area that's shaded, including this one strip of this one square, would be 0.181. Put up 10 points. Miss Reyes, next one. This is kind of a tricky one in the sense that you can see how many squares are shaded.
99.
There's 99 shaded, so I could put 0.99. And how much of this final square is shaded? 0. So you could put a 0. But you might as well just leave it as 0.99. That's all there is to it. And if you added it to 0, would that change anything? No. What if I added another 0? No. What if I added 4 more zeros? No, it doesn't matter. Okay. Wait, what if I added a 0 here? No. Doesn't matter. Doesn't matter. It's the same. Okay? So you could just put 0.99, or if you put 0.99, that's fine too. Okay? All right, let's move down a little bit here. Yeah, 10 points. So number 5 here, it says 0.6 is 10 times as much as. Now, so this is what they're saying here. It's 10 times as much as something else. So when we're talking about the powers of 10, it's either we're moving the decimal either to the left or to the right. Okay, so this is 10 times larger than what number? Miss Hicks, any idea? No? Okay. So the number is 0.6. Okay. So if I needed to come up with a number that this is 10 times larger than, I need to move the decimal one place. And so it would be 0.06. 0.6 is 10 times larger than 0.06. All right. Number 6, Mr. Wooldridge. It says 0.007 is 1/10 of something. So whatever that something is, it's 10 times larger because this is 1/10 of it. So what do you think that would be?
0.07.
Yeah, 0.07 is correct. Put up 10 points. Nicely done. Next one, I'll do that later. Miss Nealons, number 7 here. It says 0.008 is 1/10 of something. So whatever that something is, it's a little bit larger than this. It's 10 times larger. So what would that be in decimal form? 0.08. Nicely done, 10 points. And number 8, the last one right there, Miss Dart. It says 0.5. Now, before we go any further, go ahead and put up 10 points. 0.5. Miss Dart, I'm curious. 0.5 is what in a fraction? Yes, 5 over 10. Can I reduce that? To what? What number would go into the 5 and go into the 10 evenly? Yeah, perfect. 0.5 is the same as 1/2. And all of you should automatically recognize that from now on. 0.5 or 0.5 is the same as 1/2. Anyway, so let's get back to the question here. It says 0.5 is 10 times as much as something. So they're saying it's 10 times, this is 10 times larger than whatever this is. So what do you think that would be? 0.05 is correct. Nicely done. Put up 10 points. Okay. All right. All right. Let's look at these two charts right here, and let's see if somebody can fill it out completely for me. Miss Stockland, for 20 points, can you tell me what goes in all these blank squares? Now, let's start off here working with this column. It says, it gives us the decimal values here, and 10 times as much as. So, what do you think would go here?
Just 2.
Yeah, just 2. Good. And you could, or you could put 2.0. It doesn't matter. Okay. Next one down. 0.7 is correct. Next one. 0.5, or if you just put 0.5, that's fine also. Good. Next column.
4.
Yep, 4. When I write a number, if I wrote 173, where is the decimal, Mr. Texera, where is the decimal always assumed to be? I wrote down 173. Where's the decimal in that number?
After 3?
You mean right here?
Yeah. No, after.
After. Okay, so yeah, the decimal is always to the far right if you just write in a number. It's always assumed to be there. Okay. All right, just wanted to make that clear here. So the decimal, if I ask where the decimal was in the 4, it would be right here, and you could put a 0 if you wanted to, but you didn't have to. Okay. Good. Put up 20 points. All right, next column. Oh, no, I mean Miss Stockland, 20 points. You can put up 10. Mr. Malamed. So what would go here?
0.6.
Yeah, 0.6 is correct, or just 0.6. Next one?
9.
Yeah, good. Next one?
3.
Yep. Next one?
0.8.
Yep. Or just 0.8 is also fine. Okay, good. Next column down. So this is, whatever goes here is 1/10 of this. So this is getting smaller. So what would this be?
0.006.
0.06. Nicely done. Next one?
0.09.
0.09. Good.
0.03.
0.03. 0.008. 20 points. Nicely done. Okay, good. All right, next page. What'd I miss? I did?
Missed the column on the right there. No, it's the first one. Right there, see? You left.
Oh, totally didn't do that one. You're right. Miss Stockland, I was doing that one with you, wasn't I? Okay. My bad. put up 20 points because I totally missed that and you pointed it out, Mr. Clifton. Yeah, put up 20 points. Okay, Miss Stockland, what goes here?
0.0.
Yep, or you could just put 0.02. That would be fine. Next one?
0.007.
007. Good. Next one?
0.005.
005. Good.
0.04.
0.04. Nicely done. Okay, put up 20 points. Yep, totally missed that one. Thank you for reminding me.
And number 9, they say like it says 10 times as much, and right here it says 10 times as much, and we just put it 2. Doesn't matter. We put, is it the same way we put 0.06?
Because on number 5, I put just 6.
Yeah.
I think it depends on how they phrase it here. So 0.6 is 10 times as much as. So in other words, what they're saying is this number, 0.6, is 10 times larger than something. Okay, so it would be 0.06.
But
Not
number 9 is
6.
the same. Yeah.
Number 9?
10 times as much.
It's 2 bits.
So, well, they're saying whatever is in this column here, okay, is 10 times as much as this, what we're starting with. So what would be 10 times as much as 0.2? It would be 2. So I could see why that would be confusing, but yeah, 0.6 is 10 times as much as 0.06, so that would be correct. And this here is 10 times as much as 0.2, which is correct. So you just kind of have to think about how they're phrasing it. I won't give you guys any questions on a quiz or a test that are that confusing. So anyways, next page. A science teacher showed an image of a carpenter bee on a wall. The image is 10 times as large as the actual bee. Then he showed another image of the bee that is 10 times as large as the first image. What is the length of the bee in the second image? So what kind of bee are they talking about, Miss Nye? A carpenter bee. So here's the carpenter bee, and I'm underlining it in the paragraph here so there's no confusion. And the carpenter bee is, I guess, in length in meters, 0.025. And the first image is 10 times larger. And then the second image is 10 times larger than the first image. Okay? So one way to look at this might help some of you. If we're starting with 0.025, and I said, what's 10 times larger than that? I'm going to move the decimal over just one place. And then I'm going to put 0.25, because 0.25 is 10 times larger than 0.025. And then I said, well, what's 10 times larger than 0.25? Okay, I'm going to move the decimal over again. 2.5. You see how the number is getting bigger? Because I'm multiplying it by 10 each time. What if I said, what's 10 times larger than that second image? Well, I'm going to move the decimal over another time again. Now we're at 25. First we started off with 0.025, then 0.25, and then 2.5, and now we're all the way up to 25. Okay? And all of you should recognize now that anytime you multiply just a regular number times 10, you would just add a 0. So if I said, well, if there was a fourth image that was still 10 times larger, Mr. Texera, I asked you earlier, in just a number, if I wrote down a number, where's the decimal? Where's the decimal in the 25 right here?
All the way to the right.
Yeah, it's right here, okay. But if I multiply it by 10, I have to move the decimal over again, okay, because that's what I did here. So if I have to move the decimal over, it means I need to add a 0. And anytime you multiply a number by 10, you just add a 0. So now we're all the way up to 250. Each time we're multiplying by 10. But they didn't take it nearly that far. They just said, here's the first image, and here's the second image. Then they showed another image of the bee that's 10 times larger. So what's the length of the bee in the second image? So it would be 2.5. Now this is important. What? Meter. If you don't put meters, it'll be marked wrong. Okay? If we're talking about inches, you'd put inches. If we're talking about miles, you'd put miles. If we're talking about centimeters, you'd put centimeters. Okay. So it says, explain how you can use place value to describe how 0.05 and 0.005 compare. Well, let me ask you this. Which is, pull a stick here, Mr. Villegas, which number is larger?
0.05.
Yeah, good. Okay, you immediately recognize that. Okay, so you could put 0.05 is 10 times larger than 0.005. I'm not sure how else they would want us to compare those, but I mean, I think that much is obvious. Okay. Number 19, put up 10 points. Number 19, it says Terry, Sasha, and Harry each chose a number. Terry's number is 10 times as much as Sasha's. Harry's number is 1/10 of Sasha's. Oh my gosh. Sasha's number is 0.04. What number did each person choose? Well, Harry has the smallest one. Okay. So Harry's number is 1/10 of Sasha's. So Harry's number, and if her number was this, what's 1/10? Pull a stick. Mr. McWilliams, what's 1/10 of 0.4 or 0.4? We need to make that 10 times smaller. So if we're making it smaller, the decimal's going don't know? Okay. See here, 20 points. Mr. Wasowski.
It would be 0.004.
0.04 is correct. Okay. And Sasha, S-A-H-A, Sasha's number, well, they told us what that was. What did I do? S. Oh my gosh. I just butchered her name, didn't I? S-A-S-H-A. There we go. So she is 0.4. They gave that to us. Okay. And then the last number, who is that? Terry? Yep. So Mr. Wasowski, I'll stay with you. What would Terry's number be? They're getting larger.
Terry's number would be 4.
Yeah, good. Put up 20 points. Nicely done. Okay. All right. Number 20 here. How are we doing on time? Well, we're doing okay on time. An Atlas beetle. So I'm going to underline the Atlas beetle in blue here. Oh, he's not in the chart here. Okay. All right. Shh. An Atlas beetle is about 0.14 of a meter long. How does the length of an Atlas beetle compare to the length of a leaf cutting bee. Oh, okay. Well, so they want to compare an atlas beetle and a leaf cutting bee. So a leaf cutting bee, pull another stick here, Mr. Cowan. A leaf cutting bee is how much of a meter? Okay, so I'm just going to write down 0.014 for the leaf cutting bee, and then the atlas beetle, it's 0.14. So which one is longer? Yeah, the atlas beetle is definitely longer. And how many times longer? Don't know that one? Okay. How many, if I move the decimal here, these numbers would be the same. So it's 10 times longer. Okay? All right. Put up 20 points. Okay. Shh. I think we're almost done. Yep, this is the end. Mr. Paulson, it says choose the numbers that make the statement true. 0.65 is 10 times as much as what?
0.065.
Yes, nicely done. And then it says, and 1/10 of
6.5.
Nicely done. 20 points. Okay. Questions on this? Anybody? No? Okay, so we got this done here. All right, everybody pull out your math, the Go Math workbook, the standards practice book. Pull that out. Okay, go get it. Pull this out. And raise points. I want you guys to open up to, looks like it's P49. It's 3.1. And so your homework is going to be to do page 49. Okay. 3.1. And the backside.
3.1 and the backside is homework?
Yeah, so you're going to be doing that. Those two pages right there. Yeah, I'll just give you a couple minutes to work on it, then we're going to go on to something else here. All right? Possibly. Okay, let me end this video here.